of Ethereum. I helped design the protocol, I made one of the implementations, I wrote the formal specification, and generally was around. I'm going to tell you a little bit about Ethereum. But it's a talk that's a little different to my original talks on Ethereum because it's gone through a few iterations in my head. So rather than telling you about the blockchain, about transactions and signatures, proof of work and proof of stake, peer networks and cryptography, I'm going to try to explain it to you in much more simple terms, based around what Ethereum is, rather than how it works. So, blockchain, a lot of people kind of know they want it without really knowing what it is. I imagine this is actually from a 95 cartoon. All I did to change it was remove SQL database, place blockchain in there. But I think if you go around the city and you talk to some of these banks, you really do get the impression that Dilbert's coming back to life. So for this talk, let's try and forget a lot of the terminology and a lot of the ideas and concepts from the blockchain world, and try and start with a blank slate. So, what is Ethereum? Ethereum's like birds. What are birds? We just don't know. Well, that's what I thought. But now my mind's changing. Now I think actually Ethereum is a bit like this. This is a computer. Actually, this is a model of what a home computer would look like by the year 2004. This one runs Fortran, so it's easy to use. It was designed in the early 50s by a now defunct IT organization. But in many respects, there are some similarities. Ethereum, I think, is a computer. Let's think about this. We can do computation on it, as Vinay said, we can run code. It has storage, as Vinay said, giant DHT. So in many respects, it is a computer. It's a bit different to most modern computers. It's very slow. It runs maybe 5 times, sometimes hundreds of times slower than native code. Ethereum is very expensive. In terms of like kind of price parity, more or less, we're talking like 50s level of expense to have your computation executed. And it's got a slightly odd property that it sometimes doesn't decide on what the inputs are to it until maybe a little while later. So normally when we push a button and we push another button, we expect the computer to record, in some sense, the press of the first button before the press of the second button. Sometimes in Ethereum, they go the other way round after maybe 30 seconds. Bit odd. So at the moment, it doesn't sound like it's a very good computer for the year 2015. It sounds like we've sort of gone back in time 65 years. But actually it's got some very interesting properties if we think of Ethereum as a computer. Firstly, there's only one of them at the moment. In the future, I'm sure there'll be probably a few dozen, but at the moment, the thing that's special about the Ethereum computer is actually there's only one, and yet it's not in one place, it's everywhere. It's anywhere that you have access to the internet. So it's like one computer that isn't sort of, that has no physical being, it's non-localized, which means there isn't any particular place you can be in the world that will make you more able to use it, or to get you greater freedom in using it, or fewer permissions and restrictions in using it. Now that's very different to what we normally consider computers. For a normal computer, by being next to it, rather than trying to maybe SSH into it from Australia, by being next to it, I have extra sort of freedoms over it. For a start, I can turn it off. I can pull the plug out. I can put a magnet next to its hard drive and see if I can maybe corrupt all the data. I might be able to go for some sort of login or boot it into some other operating system and get access to the hard drive in an unrestricted way. There are all sorts of things I can do when I'm next to a computer rather than when I'm trying to use it over the internet. But you can't be next to the Ethereum computer because it sort of only exists on the internet. So that's a bit of an odd property. It's another slightly odd property is that you can't stop it. You can't sort of turn it off. There's no power button. No power button that's accessible to a system administrator, or a judge, or a government, or a union of governments. It just doesn't have one. And it's ubiquitous, which is another sort of interesting property. Where if you have access to the internet, then you have access to the Ethereum computer. There are more. Unlike many computers, possibly unlike all computers, it's natively multi-user. So it's like normally we have the idea of maybe the silicon has some idea of what permissions the current executing code has, whether it's able to maybe alter particular parts of the memory, or maybe it's rather able to jump into some particular part of the memory. Well, Ethereum actually has this, but like to the next level. All code runs as a particular user on the virtual silicon itself. It's natively object-oriented. Now, there are a few examples of this happening in other virtual machines, but the idea is that all code executes within its own sort of storage area. And when it wants to execute code in some other storage area, it actually has to use a message passing mechanism. This is pretty similar, if any of you are familiar with object-oriented programming, this is a pretty similar sort of concept to that. This computer can be accessed via JavaScript. It's a fairly easy language to learn. It's, many people already know it, and it gives full access to this particular computer. And very unlike existing physical computers, this Ethereum computer, you get a complete history of everything it's ever done from the time it was sort of booted up, turned on, all the way down to the present second. Now, there aren't many computers that give you such complete auditability. I don't know if there are any of this. And you get that to now and ongoing, forever, as long as the machine is running, which means as long as anybody is on this network. So in some sense, Ethereum provides computation in the same way that the internet is a global singleton for communication and networking. So there's my artist's impression of the Ethereum world computer. There's the world, and it encompasses this message passing object-oriented execution. So these arrows here are messages, and they're going between objects. These are objects. They have some code, and they have some storage. So they can remember bits about their history, store bits. And they have, their code, they can execute stuff. Now, how do we do anything with this? What's the I/O? When we use a normal computer, we normally sort of jack in a keyboard, or at least a network cable, or a Wi-Fi card, or something, some way to tell it to do stuff. Well, this computer doesn't really have any obvious outputs. Well, I'll come to them in a second. There are, however, some very clear inputs. These red boxes on the outside are inputs. They're on the outside because they're different from the things on the inside. The things on the inside respond only to messages. Can't respond to anything else. Only messages. So what we have is a mechanism of getting messages in. And we get messages in through the same crypto mechanics that Vinay's just taught us about, through this PKI, this asymmetric ciphers. So we are able to encrypt, well, we don't actually encrypt, we use cryptography to sign pieces of information, inputs, on the outside world, and we sort of shuffle them in. Now these inputs to the computer, these messages, we have a name for them. It's a slightly odd name. We call them transactions. It's mostly historic because the first one of these was Bitcoin. And in Bitcoin, it's all about finance. And of course, everybody knows if you want to change something in finance, you issue a transaction. So what guarantees do we get when we program this odd world computer? We get 6. Here's the first one. Atomicity. So, we think when we talk about databases and transactions, we can think in terms of atomic transactions. These are transactions that either happen in their entirety or don't happen at all. Now these are very handy for things like finance, because really you don't want to, if your transaction has 2 parts, it has subtract my account and increment someone else's account by roughly the same amount. You really don't want those parts splitting up and the first bit being done and the second bit not being done. It's even worse if it's the other way around, of course, and you add something to his account and then you subtract from mine and you forget that second part and suddenly you've just created money. You don't have to worry about it with this computer. All of the messages, all of the code that runs, either runs in its entirety or not at all. You get synchronicity. So synchronicity is basically, when we think of this, we think of threading, multi-threading, shared memory. We worry about operations that happen at roughly the same time interfering with each other because maybe they're operating on the same data. We don't have to worry about that. All of these objects, all these bits of code operate in their own environment and they operate entirely independently of all of the others. You don't have to worry about 2 of them operating at the same time or the same object being passed 2 messages at the same time. It just doesn't. One of the most interesting guarantees that we get is something that I certainly don't know, I haven't seen in any of the languages, but possibly has been conceived before. It's a thing called provenance. So provenance is what I'm calling the idea of knowing where the message came from. So normally, when we think of object-oriented programming, execution, messages, they go between objects. Objects each have their code. And they call methods in the other object. So these are messages going in, code gets executed. Now normally as the code, as we execute this code, we know which object we are. We can get our address. And when I say address, what I mean is just some unique identifier for this object. But normally, we can't ask, who sent me this message? Normally. And if we do, we have to worry, maybe it's been spoofed, or maybe there isn't a sufficient amount of security for us to be guaranteed that this address is actually a useful identifier. For the Ethereum, for this global computer, it's always absolutely guaranteed. It's guaranteed in one of 2 ways. It's either guaranteed through the cryptographic signature of the incoming message from the external world, that's like if it's an input message, or it's guaranteed simply through the execution of the virtual silicon as it's passing messages between these objects. And in that case, it's this sort of notion of the CPU itself, which is enforcing this addressing system. More. So we have the idea of permanence. So normally, when we turn the computer off, it forgets, in an object-oriented language, it forgets all of the fields in our objects, and we have to sort of serialize them to a database, perhaps something that's stored on disk. Maybe it gets backed up, and then deserialize when we turn the computer back again, or we run the program again. In this notional computer, this notional Ethereum computer, well, it never gets turned off, which means the object's fields never get deleted. Indeed, the objects just sort of stick around, which brings us to the second point. Objects in this Ethereum computer, they stay there forever unless they suicide themselves, unless they actually delete themselves from the computer. Now, this is very odd. Normally, a system administrator can delete an object. can just go into the database, if it's a database thing, and delete it there, or they can go into maybe, I don't know, and just pull out the hard disk and then it's definitely gone. Perhaps another object deletes it. But in the Ethereum computer, objects are immortal. The only way an object can be deleted from it is by suicide. This is odd. Finally, the code of the object is immutable. Once it has been placed in this object-oriented execution environment, it's been uploaded to the computer, the code stays the same, never changes. So for a given address, so this is just simply a way of uniquely identifying an object, that code for that object always stays the same. Forever. It can never change. It can delete itself, but that's it. Now, if the code doesn't have provisions to delete the object, then the object will never go away. It cannot go away. It's like part of this rule set, part of the virtual cylinder. Here's an example. That's a counter. It's an object. What it does is you pass it messages with a topic, and it will simply increment its little field according to the topic. So if we have a couple of external participants, Alice and Bob, Alice can pass a message in saying she likes cake. The code of the counter would then increment cake from 0, or doesn't matter, to 1. Bob can like reggae. She'll take the reggae topic to 1. Maybe Bob also likes cake. Cake comes 2. You can see this is a very simple voting. Importantly, the objects can call each other. You can imagine a marriage object. It remembers who the addresses of its married participants, in this case perhaps Charlie and Marilyn. And we can imagine that this marriage object is essentially a proxy object. What it does is it stores a message and then forwards it onwards once both of the participants have agreed to authorize this message. So we can imagine Marilyn trying to authorize the liking of cake for her marriage object. And it would wait until Charlie also authorizes the liking of the cake until it finally passed that message onwards to the counter, which would dutifully increment cake counter. Now, I mentioned before that there were inputs. These were the external accounts, cryptographically signed messages. There are also outputs. So the output for this machine is essentially the ability to access in a constant way, so you can't change, you merely look, inspect the state of any object. And when you do this, it doesn't actually cost any money. The expense of using this machine is only when you want to alter things. So we could build some sort of web-based inspection page. Let's have a look at the counter and make maybe some sort of whichever thing is winning. And that would be fine. That wouldn't cost money whenever this changed. The looking of it, the creation of this page, the inspection of the machine state, or indeed this particular object state in this case, wouldn't cost anything. So, why do we want this world computer? What's it helping with? What are the use cases? What's the vision? I'm going to go through a few of them. The first is Ethereum as an innovation commons. Because it's not got any centralized authority behind it, because it's a fair access for anybody who wants to play with it, it's sort of this, one can imagine it as a commons or a playground, a garden without walls, or at least the walls that are there are very clear, they're very open in terms of their sort of rule set. If you want to play in my garden, you're completely welcome to, but you have to abide by my rules. And it's a very easy way of, a very frictionless way of setting up these gardens. On the other hand, when we have separate servers, interoperability becomes a pain. We have these protocols, but they're not always very easy to move identities from one server to another, to have maybe 3 or 4 servers all set up, each having their own sort of business logic. It becomes very complicated, very fast, and often breaks down the very simplest thing going on. Servers also provide sort of natural monopolies, because the rules can be changed at any time, because the data can be hidden. They provide this sort of system by which an authority has a bit too much power over their garden. And servers are a bit cumbersome as well. They're a bit of a pain to set up, whereas the Ethereum computer, on the other hand, notionally is always on, and always ready to be accessed. Privacy is an interesting one. Servers, in theory, the sort of traditional server-client design does give greater privacy, as long as the server or the authorities operating the server don't get hacked. That's not so easy to guarantee. Ethereum, on the other hand, says, well, all the data's open that's actually stored on it. If you want to store something privately, keep it to yourself. This gives a much greater guarantee, as long as it's not data that actually needs to be between 2 people. For that, we don't have a problem solved, but we've got ideas on how to solve it. Security is an interesting one as well. When you go to chat to people who are still used to operating traditional server-client architectures, there's all talk about firewalls and crypto, and yeah, we're using these certificate things, and we've got this server rack set up here to prevent filtering. And it's like, well, actually, if we do it the proper way, our security doesn't need to be built around making stronger and stronger boxes with very clear holes in it for hackers to get through. Our security can be built around basically replication and clear, solid, open rule sets by which state transitions can happen. What that means is, of course, that there cannot be any break-ins, because there isn't any particular node on the network that has more permissions than any other. They all collaborate to make the emergent effect, which is this notion of computing. And finally, because all inputs to the machine are cryptographically authenticated, and that cryptographic authentication isn't just a sort of bolted on extra, but rather is built into the silicon of the CPU itself, it's basically impossible to have an unauthorized interaction. In a different sense, Ethereum could be considered the world's first decentralized computer. Almost ethereal, you might say. And if we go for I'm probably preaching to the converted here, but if we just take, well, what's the point in that one? Well, central authorities provide essentially this sort of terrible combination of providing a point of control that you can target, a point of failure that you can target, and in many efficiency terms, a bottleneck. And if we look at the way that things have gone in the past, we just think slightly sort of broader-minded for a moment, we can sort of look at other fields. In software development, in the early days, there were sort of individual hackers who sort of sat on their own in a room, probably a basement with no windows, and it was all very dark, and it had this screen that looked a little bit like Vinay's slideshow, and it was all just white sort of light on their face. And then, when there was enough money in the industry, we had this notion of the cathedral way of software development. Basically an army of coders, each with their lieutenants and eventually a big general at the top who was telling them what to do, and it kind of worked-ish, not especially well. And one of the sort of contributions to this thought in the 90s was Eric Raymond's book, where he basically said, all these guys on the internet who don't have a general seem to be doing pretty well. How's that then? And it turned out they were using these new tools. Email, CVS, versioning systems. And it's like, wow, these are collaborative tools that are actually facilitating decentralization of software development. And he called that the bizarre style. Not bizarre, but bizarre. Finally, sort of today, we're decentralizing further, and rather than having a sort of this notion of a benevolent dictator ruling, like sort of Linus Torvalds figure, we've got just forks going off all over the place. Everyone is forking. And in the 90s, the fork of a project was a terrible thing. It's like, oh no, there's like some sort of political strife going on where there's two leaders and they're fighting each other. Well, nowadays, if you look at like GitHub, it's like people consider their project being great if there's like hundreds of forks, because actually there's all of this horizontal transfer of information going on. A fork of a project isn't a bad thing because you can re-merge all the changes and you can all sort of build everything despite being semi-siloed in your own little project fork. Computing has a similar sort of through history progression. So in the early days there was sort of isolated computers sitting around. Eventually we moved to the mainframe. And before long, we had the idea of there being sort of a hub and spoke model where we have these thin terminals, and then the web came along. We have web servers with slightly thicker terminals running their JavaScript. And in the last 15 years or so, we've embraced the sort of peer-to-peer. And how was this possible? It was possible through technology, basically. It was possible through the advent of DSL, broadband, actually allowing peers to have sufficient bandwidth to be able to do anything between each other. It was facilitated by various improvements in cryptography, some of the things that Renee mentioned. But basically, as technology has facilitated, the infrastructure has moved towards the edges. I'm no historian, but it doesn't take genius to realize that as time has gone on, decision making in society has decentralized in general. From anarchy, we sort of build first sort of fiefdoms of monarchies, and then this sort of eventually sort of collapses into an aristocracy and fans out into what we have now, which could sort of be argued to be more of a bureaucracy, but on the face of it at least democratic. Distance sales is also sort of an interesting one to look at. Back in the magazine, you would phone up and be like, I don't know, adverts for public domain software or whatever, and it wasn't a great sort of trade system, but it more or less worked. And then Amazon came along. Now Amazon was pretty cool because it was they provided basically this huge supermarket online. Huge supermarket, but it was just one supermarket, right? They were the one seller on their platform, and they were therefore, their platform was essentially matchmaking to themselves. So it was a single catalogue, and they were the ones that operated it. And we can get Amazon Marketplace and eBay, which could arguably be considered one of the first major decentralization efforts of the internet, where trade, in some sense, is decentralized. eBay still is a centralized entity, of course, but the participants, the actual goods, are coming from a very much decentralized space. Many merchants, still one matchmaker. In the future, I expect actually we'll move to a platform where even the matchmaker, the matchmaking mechanism is decentralized, as well as the merchants. Communication follows a roughly similar path. We start with sort of this centralized press, radio, and television, eventually to the internet, which is still kind of centralized. It's maybe a little more federated than centralized, and maybe eventually we'll sort of decentralize further and move to things like mobile mesh networks. So why? What's the general theme? Well, the general theme is you start with kind of nothing, or just this chaotic mess, and you get order by strength, basically, by a strong individual who's actually, it's worth it to them to build and enforce order. And we get centralization. And the centralization enforces order enough to build the scaffold, to build the technology, to develop things sufficiently far that decentralization, decentralized way of doing things, autonomous cooperation, can actually succeed. It can't succeed in the early days, but it can succeed when technology has gone far enough through centralization to give it that those water wings. And why do we decentralize? We decentralize because it actually delivers economic benefits. Decentralization, by and large, is more scalable and more resilient. So one of the other things, exploring what Ethereum is, well, it could be considered a means to commoditize trust, or a bridge across trust boundaries. And you'll find that many of the key use cases for Ethereum are built around this idea of taking an industry that originally had a trusted authority sitting in the middle, taking their pound of flesh with every transaction, and basically getting rid of it. And in that sense, it could be considered a platform for zero trust computing. Because most of these intermediaries don't actually do all that much. The key thing that they do is they sort of dress in suits and they stay in the same buildings, very old buildings usually, and you know, nothing has changed, which means they must be doing all right. They must be a safe pair of hands. In terms of the computing, of course, the sums that they tend to do tend to be quite simple. And so we can imagine it as a platform for doing the sorts of things that we would normally need these trustworthy institutions to do. Things like permissions management, smart contracts, autonomous trading, finance, and so forth. We can also imagine Ethereum, and Vinay sort of touched on this, as the sort of courtroom of the internet. Not in the sense that it's going to replace judges, but more in the sense that it's a way of encoding procedure. And that's actually the important thing about the courtroom. Courtroom's really just a place for procedure. It has its inputs and outputs. Its inputs and outputs tend to be the expert witnesses, perhaps a panel. But the important thing is that when these are in place as necessary, that there is a procedure for taking initial sort of statements and determining their validity and potentially eventually enforcing some sort of judgment. And Ethereum can provide perfectly good means of digitizing that process. And in this sense, we can think of Ethereum as a platform for crypto law, just as kind of reasonably happy with the idea of Bitcoin being cryptocurrency. Well, Ethereum provides this ability to digitally, cryptographically enforce social process. Ethereum also has its role to play in the serverless internet, the decentralized internet. Essentially, it is able to perform the logic that we would normally place on a well-secured server. This is the sort of logic that makes sure the database is operating correctly. This is the sort of logic that looks after the atomic transactions, the things that actually make the platform trustworthy and work in whatever way it needs to be done. Seen in this light, it would be combined with a bunch of other technologies, some form of decentralized data store, maybe BitTorrent-like. In this case, there's a couple of sort of newer people to the party, IPFS and Swarm, something that's developed within the Ethereum organization. There's a notion of a dark messaging service, not dark as in, you know, oh, it's used for terrible things, but rather dark because the routing of the messages are themselves kept private. So it's difficult to collect metadata, unlike many other methods of communication. And yes, Ethereum would sit there as the means of coordinating these interactions. So very quickly, what may be the use cases for this big computer? Generally the things, as I said before, the things that cross trust boundaries. The supply chain is a very clear use case. Yutta's probably going to mention this in detail, but the basic idea is that the supply chain has many participants. They don't necessarily trust each other. They do need to, in some sense, hand off information. They need a platform to record these handoffs. There can be that platform. decentralized finance, we have the idea of vouchers, tokens, things that are very naturally decentralized because we want to push the expense of recording the movement out to the edges of the graph rather than bundling it up in some central server that breaks down or that's costly to run or that gives an authority too much power over what these things are. And prediction markets are an interesting one, but basically the ability to source information from the crowd and have it all gathered in the open enough that we trust the mechanisms that we're willing to put our money in. Okay, yeah, I'll take a few questions while Jutta sets up. Anyone?
When you say that Ethereum is completely decentralized, I've been involved with discussing decentralization projects since like at least 2-3 years or so, in some depth. And if I look at this global computer is a software platform, right? So there's some kind of basic code that is running somewhere, and that comes from a central development group, right? I mean, the final authority about what becomes part of Ethereum is like Vitalik Buterin, some people actually in the development group. And so that's one point. Maybe you can say something to that. I mean, that's basically in any decentralization project, you will have people who have the authority to change the code. And of course, other people can fork something, but they will not be able to easily compete once you have an established platform.
Okay, so I can say something on that. There is a code base, that's correct. Actually, there are many code bases, probably all of them slightly different. It's been forked many times. And of course, I can change the code in that code base. I can't change the code in some of the other code bases. Other people can change the code in their code bases, but probably have to do a pull request in mine. So I, as one of the lead developers and one of the implementers of the protocol, I have authority to change the code on my computer. I have the authority to change the code in one of the GitHub repositories, but I have no authority whatsoever to alter the fundamental protocol of the network that other people run on their own machines.
So Ethereum is a protocol specification and not this with the code.
There is code. There is lots of code. But Ethereum itself is a network. It's a network of people who want to run some software. And they can even choose the software. They could code it themselves. 3 people already have it. And they take part in the network. So I think it's calling Ethereum centralized because there is a code base that 7 or 8 people contribute to and tends to be recognized as one of the main code bases is sort of largely. Yeah.
No, I suppose I have 2 quick ones. One is that blockchain is known to be growing in size dramatically, so it's good to see how that can work if you start adding data, bigger data to the blockchain. So the obvious answer to that is to start putting links into the blockchain to information on the web, for example, where you can store terabytes of data and it will link.
That's pretty cool.
That's what you were speaking about, the Web3 part. The question is, if you put data into the blockchain, you want it to be globally understood, this data to be globally understood and have a global way for me to know, well, this data here means this, right? So you need a data format that is globally accessible, understandable, out of context, because you have a global computer with no context. So it seems like this is what the semantic web has been building, right? A logical space, a logical vocabulary for building distributed linked data. This would allow you to put data into the blockchain that can be understood globally, but also to put some parts of the data out onto the web when it's not needed. So, but once you start imagining that, am I right? Is that possible? Is that a possible way to go?
So the semantic web is an interesting idea. You're absolutely right in that the blockchain protocol of Ethereum as it stands is not particularly scalable regarding the provision of storage of data. And you're right to an extent that placing references to data within the blockchain can be a solution for a set of problems that require large amounts of data. So this is essentially the case when the data itself doesn't form an important part of what the inputs to the code that is running on the machine are, but rather it's simply something that we want to tag. So for example, suppose I say, right, well, here is a photograph of me. My account on Ethereum, people trust is actually me, but they don't know what I look like. What I could do is somehow take that photograph and place it in some sense, the Ethereum computer associated with that address, that account. Now, one way of doing that would be actually to upload the photo to Ethereum with that account. That's one way. It would waste a lot of space in the Ethereum network, especially if it's like an uncompressed PNG that's like super high resolution. What do we do in that instance? Well, we hash the data and we put the hash on the thing, which is much smaller. It's like 32 bytes. It's very small. Now, attaching semantic information to that in a way that is meaningful, I think it's an interesting experiment, I wouldn't discount it, but I think it's something that I would leave to see how infrastructure sitting within the blockchain, so contracts sitting within the blockchain, try to do it themselves. For example, if I want to associate myself and somebody else, maybe I say that they're a friend. So I want to attach a semantic piece of information to two accounts. I think rather than trying to design protocols that necessarily think in terms of sort of HTML tags, I would try to design a contract that had at its sort of base a means of attaching this link between two identities sitting within Ethereum with perhaps some attribute bestowed on it by the contract. So maybe it's the friend contract, and then I'm saying, right, this person is my friend, and what it does is it records that I think they're my friend, and until they record that they think I'm their friend, it just sort of sits in some pending state.
I think the very interesting thing is that it's now where it's built at the logical layer. So it's really coming out of mathematical logic, and what it does is it gives everything a global identifier as an IOI. So as long as you have IOIs for people, which people in blockchain have some global identification system, then you can have there's the node relation already for HTTP /////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////// you can even, I think you're probably using JSON, some kind of JSON format to store the data, right? In blockchain, because you're speaking about JavaScript.
No. JSON is limited purely to the sort of notional user interface side. Within the blockchain, everything is as stripped down as it can be.
All right, so whatever your format is, then you
Sounds like
put
a conversation to be taken to coffee or pub.
Yeah.
Yeah. All right.
Deep
Anyway, it's
tech,
good
deep
to-
tech.
Cheers.